Now, finally we get to learn the chapter 12, lesson 1. The first lesson is called angles on a line. They are angles like this. Look, AB is a straight line and D is a shared vertex of two angles, angle ADC and angle BDC. So these two angles, they share the vertex and the two sides of them make a straight line. They are called angles on a line. One important property of angles on a line is the measure of this angle and the measure of this angle make 180 degrees. So this is how we can write it. Measure of angle ADC add measure of angle BDC is 180 degrees. Why is that? Well, we know that on a straight line, we can draw one and only one perpendicular line to it. And this perpendicular line makes two right angles. One right angle is 90 degrees and two right angles is 180 degrees. So, the sum of the measures of these two angles will make 180 degrees. Well, do you think it only applies to two angles? Or it also applies to 3 or more angles? The concept of angles on the line. Yes, of course. When you have more angles, let's draw it straight line like this. Even when you have more angles, if they share a point, the vertex, and their two sides of their sides make a straight line, they are still called angles on a line because the sum of all of them still makes 180 degrees. Just like this one. Okay, I'm going to go ahead and show you the sentence. The sum of angles measures on a line. Well, the sum of angle measures on a line is 180 degrees. And just like this one, these three angles are called angles on a line.
All right, it's day 2 of our Earth Systems slideshow video presentation. And we're going to focus on these two questions today. What are Earth's layers and what are landforms? So by the end of the video today, you will be able to answer these two questions. However, what are landforms is it has lots of answers to it. So I don't expect you to know every single landform, but you'll need to know quite a few. So that takes us to our first slide. What are Earth's layers? And the Earth is composed of 4 layers, 4 basic layers here. The crust, the mantle, and the outer and inner core. So the core really could be considered one piece, but the two parts of it have different characteristics. So you can go ahead and take notes on the bottom corner here. This information right here. So the crust is the thin, rocky outer layer. You can imagine it like an orange peel or an apple peel. They're very thin, and most of the apple is not the skin, and the same thing with the orange, but you can peel it off. It's a thin layer, and that's where most of the landforms are and that sort of thing. The mantle is the thickest layer, and it contains some liquid rock, but it's mostly solid. Most of it is solid. The core has 2 parts. It's the most inner part, obviously, because it's the core. It's the center of the planet. But the outer core is molten liquid metal. So that means that the metal got so hot that it's melted, and it's like an ocean of liquid metal. Only it's not exposed to the surface. So it's this liquid metal between the solid mantle and the solid inner core. The inner core is made up of iron and nickel, and it's very dense, and there's a lot of pressure. If we were to drill a hole down to the core, we would probably be crushed by all the pressure. It's just that it's very, very, well, it just has that much pressure. You'd be crushed. All right, and this is a good image of what the Earth would look like. Obviously, this is something an artist has done, but you can kind of see that the Earth is composed of a ball within a ball within a ball. So we have the crust, the mantle, which is the thickest part, then the inner and outer core here. Here's the outer core, here's the inner core. So this outer core is the one that is primarily liquid metal. All right, Earth's plates. Now the plates, there's a theory called plate tectonics, and that is the theory that the Earth's surface is a collection of like jigsaw puzzles that are constantly moving. It's divided into layers, and it's when these layers, it's when these edges collide together is when you get earthquakes and that sort of thing. So looking at this isn't precise, but it's not bad. You have these black lines here. So Africa is floating on this big plate here, and the Earth is, the surface of the Earth is kind of constantly moving. I think scientists determine that different plates move at different amounts each year, but it might be a millimeter or two or a couple centimeters a year. And once again, that's kind of what causes a lot of our earthquakes, are these plates bumping up against another one. The important information for you to know here is the theory, what plate tectonics is, which is the theory that Earth's crust is divided into layers and are always moving, and also know what a fault is. A fault is a break in the Earth's crust where rock can slide against each other. So that's, the fault is where the earthquakes happen. And there's a couple different ways that the Earth can slide against each other. Each plate can slide against each other, and we'll see that in the next slide. All right, we have one here, a ridge where the two sides are moving away from each other, and if they're moving away from each other, that means it creates kind of a hole or a gap. It's spreading apart, and usually that's a result of volcanoes. Volcanoes can pop up there because the liquid metal can, or the magma can come up in those holes. Then you also have something here called subduction. So subduction is where one plate slides under the other one. So here, this is butting up against this one, and here the plate is going under the other one. And it can be very destructive, and that's what causes a lot of buildings to get destroyed when an earthquake happens. It can also cause tsunamis and that sort of thing. It can create a trench. So in the ocean, we have these deep, deep trenches that are caused by this. And of course, a trench, it's not a hole, but it's like a valley in the ocean floor or on the surface of the Earth. And then we also have one where the two parts of the plates move, they slide past each other. So one would go that way, one would go that way, and it doesn't do much to the landscape, but it does cause some damage. So we have, well, those are called divergent, convergent, and transformation. You don't need to know the different kinds of, well, you don't need to know how the Earth has these earthquakes and what these ridges cause, but I want you to be aware that these are faults right here. Those are all faults, and that they can cause earthquakes. All right, the theory of continental drift. I touched on it slightly a few minutes before, but the Earth is Scientists believe the Earth is floating on the tectonic plates, and the plates drift over time. So the theory is that millions of years ago, all the continents were one supercontinent, and then they slowly started to break up, and so that's called Pangea. And over millions and millions of years, the surface of the Earth has changed because the continents are constantly moving. So you can see different projections of this. If you were to go on the internet and type in continental drift, you would see different projections of it, people think it looked like. And this is what we have today. And they project that in millions and millions of years, this will look different, and that the continents will continue to drift and bump into one another. All right, we're not going to watch this. Now we're going to go into landforms. All right, so landforms. We know our basic landform features. There's plains, hills, mountains, canyons, sand dunes. Basically, if you can see it on the surface of the Earth, it's a landform. So here's we have mountains. Glaciers are a landform. Rivers, a harbor, a peninsula. Down by Bihayuntian, we have the bay, basically. The beach is a landform, and the bay is a landform. And the river that runs into the ocean, that's called an estuary. That's a landform. So there's all sorts of landforms here. We have some more examples here. There's a beach, lake, peninsula, river, gulf. Here a gulf is like a bay, but it's the ocean going further inland. We have a cape. A cape is where a piece of land juts out into the ocean. And it's also a peninsula, but it's usually a little bit thinner, not as wide. Deserts, estuary. An estuary is where fresh water flows into the salt water. And so we have one of those fairly close to where we live. Glacier, of course, is ice sliding down a mountain. Hills, an isthmus. An isthmus is a narrow strip of land that is connecting two different pieces of land, but it's surrounded by water. Valleys, mesas, mountain, canyon, islands, cave, crater lakes. Crater lakes are lakes that develop develop inside old volcanoes. So of course we have oceans and buttes. Buttes tend to be out in desert areas, and it's basically, they're not mountains, but it's where water has somehow washed away sandstone and that sort of thing. So caves, cliffs, canals, canyons, mesas, there's gulfs. You can read the list here. The important thing I'm going to say is that you write down a list, I'm going to say, of 10 to 15 different kinds of landforms. All right? You'll need to be able to name 10 or 15, well, let's say 10 different kinds of landforms for the quiz on Friday. All right. One important landform is a volcano. Now, it's important because a volcano creates more land. And it does that as an opening. An opening allows magma to reach the Earth's surface. So that could be through a fault. It could be, well, it's through a fault. And the magma rises to the top, and it creates a mountain, more or less. As the magma flows up, lava flows out, and it builds up and up and up. And it's the heat and pressure that cause the magma to rise. So if you shake up a bottle of soda and open it, it's going to explode. And that's because there's pressure in the bottle from all the carbon gases exploding inside of it. And it causes, once that pressure is released, it explodes. So it's the same idea with a volcano. So you will also need to take notes on this. You can go ahead and write that down.